In this video, we'll learn what to do when you have a Lewis structure that has more than one possible correct structure to it. Remember, we said in the last video that the best Lewis structure is the one that has the fewest formal charges on it. But sometimes we'll get into situations where we can have two two possible structures, but each one has a formal charge on a different atom. In this case, situation 2 and 3 below both have a Lewis structure where the formal charge is -1, just on different elements. So which one is correct? Well, when you have the situation, the correct structure is the one where the formal charge is on the most electronegative atom. In this case, the Lewis structure on the far right, number 3, is the correct structure. Now, sometimes we have situations where we can draw a Lewis structure and the formal charge works out, but we can have something like a double bond in more than one place. Here is the Lewis structure for ozone, and you can see here that we could draw the bond on the left oxygen or on the right oxygen. This is a case where we have something known as resonance. Resonance is a situation where you have the same connectivity of atoms, however, the double bond can be placed in more than one spot. That is, the double bond is mobile. Since the double bond can move between the two oxygens, we describe this as having two Lewis structures which are equally correct. So what's really going on? Well, we get into a situation known as resonance, and resonance basically will take something like a double bond and stretch it over the whole molecule in the region where the double bond can be placed. In the case of ozone, the double bond can be placed either on the left or the right, therefore the correct Lewis structure is both. That is, the double bond gets stretched over all three oxygen atoms. Just like if we take two colors, blue and yellow, and we bring them together to form green, ozone has two double bonds, one structure on the left and the one on the right. Both are equally correct, so the two double bonds get stretched over the whole thing. That is, ozone is a combination of two correct Lewis structures. Now, when you have a double bond that's stretched over multiple spots, we say we have resonance, and that the double bond is delocalized. That is, the electrons are free to move around both locations of where that double bond would be. This is different than electrons which are localized, in that localized electrons are trapped directly between two atoms. Delocalized electrons have mobility to them and they're not trapped. Take, for example, benzene here. Benzene is a structure where we have alternating single and double carbon bonds. Therefore, the resonance structure can be shown as a ring in the bottom right-hand corner, showing that the resonance structure allows the electrons to move on the inside track, that is, they can move over all the carbon atoms, but not the hydrogens. Now, if you're worried about where did the hydrogens go on that bottom set of Lewis structures, this is part of an organic notation which is beyond the scope of this class. But what you should take home from this message, or from this slide, is that the double bond is free to move around all the carbon atoms, resulting in a delocalized structure. Now, if you're worried about trying to figure out what resonance is, we'll see some more examples of this when we get to our problem-solving videos.